If you always like to break things, inject failures in your system and just see how it reacts, then it means that you're probably a chaos engineering. If you do, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of an existing series, the SREs, where we already had an episode explaining how to get started using SLI and SLO. Today's episode will be focusing on explaining what is chaos engineering, and we will take the opportunity to interview one of the contributors of one of the very popular CNCF projects, Litmus Chaos. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We will start with a brief introduction, then we will explain what is chaos engineering. We'll also list the various chaos engineering tools of the market. Then last, we will do an interview with one of the core maintainers of the Litmus Chaos project, Sayan Mondal. Of course, if you're looking for the tutorials, be patient, there will be a second part covering Litmus Chaos in detail. Several years ago, we used to build our application, test, and deploy it in production. Our system at that time were fairly simple. We were trusting on our ops team to deliver stable instances, network, and more. But you know, in real life, we don't necessarily have the expert, the firefighter, the secret agents of the production that is proactively working to make everything in order for our production environment. In fact, it happens quite often that we are facing major outage due to simple and basic problems. First, our environment since several years has become more and more complex, mixing cloud instances and on-premise data. We are utilizing SaaS solutions and even more. In this environment, the risks of failures is very, very high. So how can we proactively manage potential disruptions that could generate major outages for our users? Well, chaos engineering. Chaos engineering is a strategy to discover vulnerabilities in our distributed systems. The concept is simple. We will inject failures, errors in our application. Of course, we need the right level of observability to see how our application behaves when we inject those errors. At the end, with chaos engineering, we will be able to cover several things. First, we will be able to identify weak points in our systems. Second, we can see in real time how our systems respond to pressure, to failures. 3, we will prepare the ops teams, the engineers, the SREs for real failures. Last, we will identify bugs that could cause system-wide issues. We are not breaking things just for fun. We are trying to discover issues that could impact our environment and even more, impact our users. If we look at the standard definitions that is provided by Wikipedia, here it is. Chaos engineering is a discipline experimenting on software systems in production. Am I dreaming? Did he mention production?
Yes.
Oh. Well, before having fun in a production environment, I think we should first measure, observe the impact of our experiments in our application in a non-production environment like staging, pre-prod, performance, well, you name it. I will say, don't improvise in production. Once you have enough maturity, you can think of running your chaos experiment directly in your production environment. Chaos engineering has a precise workflow. Step 1, we need to define hypotheses. The main idea is to identify what could fail or what could go wrong in our environment and predict how our system will react against those errors. To control our experiments, we need to determine which metrics we need to collect that will help us to measure the impact of our experiments against our application. So it could be latency, memory usage, network issues. Depends on the experiments, you will have to determine that. And of course, we're also fishing for customer metrics. We need to measure the impact of experiments or outages on our end user. Keep in mind that we don't want to go too far and generate just outages. We want to generate issues that are relevant. And we want to measure, for example, the error rates from the user perspective, the response times when those errors happen. Step 2, we need to define the workflow of our experiments. If you want to run this outage, you probably need to trigger certain failures in a certain order. So you have to determine that workflow. Then we have to also determine how to roll back our experiments in case of major issues. Remember, potentially those experiments will run in production. Last, the process to collect our key metrics, events, whatever you want, you need to define how you want to measure and how you want to retrieve those measurements from your environment. Step 3, we run our experiments and we analyze to validate our hypotheses. If our hypotheses were wrong, we need to resolve potential issues and probably adjust our hypotheses. Let's have a look at the various chaos engineering tools available on the market. So first, of course, Chaos Monkey. It's the original tool created by Netflix. It came out in 2010 and Chaos Monkey is still out there and has regular updates. It's based on the Go language. Gremlin. Gremlin helps clients set up and control chaos testing. There is a free version of the tool that offers basic tests such as turning off a machine or simulating high CPU load. Chaos Toolkit. This open source initiative makes tests easier with the Open API and a standard JSON format. Pumbaa. Pumbaa is a chaos testing and network emulation tool for Docker. Chaos Mesh, a very powerful chaos engineering platform for Kubernetes. Mangle, it's a tool that has been built by VMware. And of course, one of the incubator project of CNCF, Litmus Chaos. We will try to introduce Litmus Chaos on a dedicated episode, so if you're fishing for information about Litmus, stay tuned. There will be a dedicated episode soon. Alright, we just listed various chaos engineering tools and platform, right? And I think we deserve to get more details related to the practice of chaos engineering. For that, we have the honor to get a special guest. It's one of the contributors of the CNCF project, Litmus Chaos. I would like to call Sayan Mondal, who is a contributor and maintainer of the Litmus Chaos project. Hi Sayan, how are you?
Yeah, hi everyone. I'm great, I'm doing great, and it's an honor to be here as well.
I have a few questions related to chaos engineering, and then specific related questions related to the Litmus Chaos project. Before we jump into the actual questions, could you briefly introduce yourself and remind us when did you start contributing to the Litmus project?
Alright, so I am Sayan. Once again, I am the contributor and a core team member of the Litmus project. So I joined in around 2020 in this whole adventure, And I think Litmus 1.x was out by then when I joined. And I basically moved into the know-hows of Litmus 1.x, and I figured out some things could be improved. And that's when me and my team jumped into the UX part, lots of feedback from the community, and then we shifted to Litmus 2.0. And now we are at Litmus 2.x versions, multiple versions of patch releases.
Perfect, thanks. I briefly presented chaos engineering process and introduced few tools that are currently available in the market. It seems that chaos engineering practice has changed with the explosion of cloud native technology. Do you think that the tools and the overall chaos engineering practice has evolved since the cloud native revolution?
Sure. So when we think about chaos engineering, probably the first thing that comes in our mind is Chaos Monkey, because that was one of the tools that changed the idea, how we perceive chaos engineering. And we also took from what they had to offer, what Netflix had to offer. And then we saw a gradual rise in the adoption of chaos engineering in the wide market. So we have a graph which we call as early adopters and late majorities. So chaos engineering, specifically cloud native chaos engineering, is somewhere in the early adoption stage where a lot of industry people are adopting the practice of chaos engineering, whereas Kubernetes is mostly towards the majority side, because a lot of industry are already relying heavily on Kubernetes. So the thing about bringing chaos engineering into the Kubernetes space and into the cloud native space is something which is really important. And that's what we think that we would be covering the cloud native section, so that we can deliver reliability on individual microservices rather than just targeting the entire system, which was the idea that Netflix came up with initially, that you target an entire chunk and then you see how resilient that particular application is. But what the industry is now currently, what stage it is currently in, is we are not having a singular, monolithic application. It's broken down into multiple pieces, and we need to target individual sections to find out what is the problems, or what are the problems not only with your application but with your stack, with your infrastructure, with your cloud native services. So yeah, that's where the industry is currently, and that's where I think most of the tooling is also developing these days, and that's where everyone should be heading.
I never tried Chaos Monkeys, but I have followed the solution by reading several blogs. And from my understanding, Chaos Monkey is mainly a platform where you are randomly generating failures and injecting errors. I come from the testing world, so I'm very uncomfortable about the notion of random, because running tests or experiments will technically discover issues for us. So I may want to repeat the test to confirm the observation or to validate that the issue has been resolved. What is your opinion on this? Do you think that random makes sense, or designing chaos test case or experiments is a good practice to gaining confidence, and then once you are mature enough you can turn on the randomness experiment? What is your view on this?
Yeah, so initially the randomness was definitely there, because it was the chaos engineering space was very new at the time. But my personal opinion is there should definitely be a plan, and that is also something where the game day logic comes in. So game days, for some of them who don't know what game days are, it's like basically a practice, or like a task, or a schedule where basically everyone comes in, they have a plan that we are going to execute these things, we are going to deliberately test and fail, or try to fail, or inject some kind of chaos in our application and see where it goes. So definitely there's a plan there in the game days. They don't just randomly throw a bunch of experiments. Rather, there's a sequence that we need to first check if our node is correct. We need to see if we do a packet loss, what happens to our application if some outage happens. So there's an outage, there's a scenario in mind, and then we basically try to imitate that via different chaos experiments. we chain them, and then we execute those in the predefined manner in a scenario basically. So that's how the notion from randomness to a stable sequential chaos engineering came into place. Because with cloud native also there's different kind of applications, right, that you need to target, let's say Cassandra or Mongo or something. So you can't just randomly throw experiments there, so you have to have a predefined plan. But that's also fine if you do it random, you'll get a false case, a verdict that it failed. But it doesn't make sense because chaos engineering is mostly about like testing things when you know that the system is already resilient and I want to test it out if it fails or not.
If someone understands the value of chaos engineering but have no clue how to start, what would be your recommendation?
Since chaos engineering is not just about cloud native, it's also about the entire ecosystem, where it might be cloud native, it might not be. So generally, I would definitely recommend reading about the practice of chaos engineering, the three important steps: the steady state, the hypothesis, and the adaptation. So these are like the principles of cloud native or just chaos engineering. And also, there's a wonderful blog by the principles of chaos engineering.org or something, if I am correct, which talks about the four principles of chaos engineering, cloud native separately and chaos engineering separately. So it gives you a great idea of why I should be doing this kind of a practice. And also O'Reilly publishes amazing books about chaos engineering, so that could be another starting point for people who want to learn about the principles, about the core functionality of chaos engineering.
On the first step of chaos engineering method, we have to define hypotheses. How would you list or detect the weakness of the architecture? Would you first implement an observability platform to collect data, events, metrics, and then from the observation, take some decision?
Well, what I personally do, what we mostly do in my company is basically we first identify the steady state, and the steady state is different for us because everyone views the steady state differently. So, for example, if let's say we have 3 pods and it's doing some connection with the database, it's sending data to the database. We have a Mongo stateful set, for example. So, the idea, my steady state would be, let's say there's an outage, there's a network outage. What happens if my pod is not able to connect with Mongo? So that could be one idea, that could be one scenario. So that is the steady state for me, that if there's no outage, maybe do not crash the system and let the users know that there is an outage, or maybe make an air-gapped system where you are able to store it in some kind of session storage or local storage, something like that. So that could be one steady state that I'm thinking of, that if you do a packet loss or a network loss, a black hole attack or something, then this is the outcome that should happen. So that is my steady state. So I have that hypothesis, and then I go ahead and pick up a particular experiment, let's say black hole test and packet loss or something, network loss experiment, and then I throw in that, and then I do the chaos experiment, and my result should be equal to what I just thought at the beginning of my chaos experiment. If I do that, the chaos is successful. Now I try to go to that particular deployment and I see what happens if I try to enter the data, and then I see, okay, so it's saying that it's not able to do it, or my data is successfully stored in my local session. So if that is successful, then that means my chaos scenario was successful. My hypothesis was equal to the steady state that I thought of. So my application is back to the steady state again. So that is something I personally do in my company, and most of the people in my company also do. And another thing is a great way to observe what your applications are going through is basically like attaching and integrating some kind of observability solution to your applications, to your particular infrastructure. And you can check for maybe a QPS, or if something drops, then what exactly went wrong, which particular pod was affected, what is the time gap, why that particular service is out of, why it was in a timeout state. So those kind of metrics would really help. So you can integrate an observability solution beforehand. That is a different kind of approach, but you can also define your steady state first and then check with the observability tool that if what I thought of was correct from the help of those metrics.
When looking at the definition of chaos engineering, it says injecting failures in production. I mean, my first reaction was, no, never in production. I need to first practice, learn how the system behaves, recover, gaining maturity, and then start running experiments maybe in production. When should we start applying experiments in production?
In chaos engineering, is generally test the system when we are confident enough that our system is perfect, not perfect, but like our system is resilient, and we know that it is a complete system, our infrastructure is strong, and now we want to test if what happens when there's an outage. So definitely you should always do this when you're confident about your application. So if the question comes in mind that the production will try to break everything and what happens to our users and everything, which is actually true. So what we recommend doing is do these kind of experiments in, let's say, canary deployment, or maybe a blue-green deployment, or let's say you have a staging environment or a pre-production environment where you have the same sort of setup, and then you inject chaos in those kind of environments where you are safe from any kind of outages happening that would affect the users, and you are also confident and you can try out any kind of experiments that comes in your mind, any kind of scenarios, without the fear of affecting your users. So I would definitely recommend doing this in a pre-prod or a staging environment. And also another thing which we can do, or a lot of people actually do, is do these kind of experiments on the CI pipeline before they actually hit the production. So if there's some problem with there's some outage that it has detected, your experiments have detected, so the build will fail and you will not be able to push it into production. So you would know that there's some kind of problem you have to fix, and you can try again. So CI is also an option. But if you want to see the full-blown setup, we would definitely recommend doing it in a staging environment or pre-prod.
So you basically run production experiments against your canary releases or blue-green deployments. Thanks for all those great recommendations. Let's jump into the Litmus Chaos questions. So first of all, I've been using version 1.3 several months ago, and then a few months later, I had the chance to discover that Litmus has been upgraded, and I used the release 2.1. And I discovered the web UI that you just described, the Chaos Center. By the way, I think Litmus Chaos has improved a lot. So first of all, congratulations and kudos to all the people contributing to the Litmus project, because the platform is really amazing. I'm pretty sure that most of the people watching are interested to get news about Litmus. Since I played a lot with Litmus, I think that adding integrations, extra integration, could clearly help our community by providing new type of experiments, collecting more data. Are there any plans, work related to any integration with existing Kubernetes solution like Flagger, Ingress solution, Service Mesh, crossplane?
Yeah, so we do have plans for these kind of integrations, the other toolsets that you mentioned, because what we've observed in this past year is the industry is, the cloud native industry specifically, is going aggressively on the CD side, the continuous deployment side. So what we want to do, or what is in plan, is basically that one integration is already there, which is with Istio. So if there's a cluster that is running Service Mesh with Istio, then Litmus can wrap around it, and Litmus, you can inject chaos experiments or chaos scenarios with Litmus with a cluster that is running Istio. So that is manual step, but that integration is there. And also another integration that is on the pipeline, we're working through it, is with Iterate. So you can basically use iterate to validate your SLOs, and then you can use Litmus on top of that to help with like enhance or bootstrap those efforts with validating your SLOs with different kind of test experiments. So
I had the chance to read lots of content related to kube costs. And in fact, I'm planning to create an episode related to this solution. I really like the approach of having a component that connects to our cloud provider and retrieve the current price and expose them as a Prometheus format. I was thinking that maybe we could design experiments where we expect any impact on the cost. Have you already thought about that?
Yeah, I mean, this idea sounds really great. We already knew about kube cost, but the idea that you just mentioned is definitely an interesting one, which we had different versions of this idea in our discussions, but this is definitely a good one, and we would definitely take it to the team and discuss about it. But yeah, this is a really good idea that it also tells you about how much cost it would be affected if you do that, if this kind of outage goes in, or if you had a failure in this particular node, and this is resulting in a chain of all these different ports you have, so this much price.
Yeah, I think it could be very interesting to get, especially when we're using solutions that will auto-scale our workload. We could basically inject failure and then measure the consequence on the costs of our applications. Do you have any features that are currently working on? Are there any plans to provide connection with CI/CD solutions or ticketing solutions, or simplify the scheduling or the automation?
Yeah, I mean, for these kind of automations, definitely we had to automate it because the industry is moving with automation. And that's when we also came across this idea of GitOps. So GitOps is really hot in the market, and why not use Git as a DB? And then whatever you do, it's a bi-directional connection. So if you do something on DB, it will trigger the scenarios or experiments in your particular Litmus kiosk environment. So yeah, that feature we thought of, which is currently there. And what is not there, which is in the pipeline, is something that you also mentioned about the alerting system, which is definitely it's a plus point. Something like Alert Manager, which can help identify and give users the result that, okay, this went wrong, you need to do something better, this is the metric that is failing. So that is in the pipeline, that is in development right now. And some additional things that we are planning that's in our roadmap is basically increasing support for the non-Kubernetes infrastructure components. And also there's a Chaos SDK that we use. So we want to improve the Chaos SDK to support more kind of more user-defined experiments, so that they get a variety of choices when they are creating the scenarios with this Chaos SDK. And currently we have 4 probes, which is I think, yeah, there's a CMD, JTest, PROM, and the HTTP probe. So we want to add the support for the probes that users can add, so that they can do more kind of plugable checks.
Is there any other news you would like to share?
Yeah, I can add 2 more points, which is basically we are focusing more on the not more than other features, but this is also in the pipeline that we want to add more application-specific experiments, because currently we have a plethora of generic or like specific experiments, specific kiosk scenario-related experiments, but we want to target applications as well. So let's say a Mongo specific, or like currently we have VMwares, we have GCP, and those kind of AWS experiments, but we want to be versatile and target more applications. And then we want to improve the observability, obviously, because currently we have support for Prometheus and Grafana.
Okay, that would be great. I remember 2 years ago there was an alpha version of this with Gremlin. I thought it was really interesting, but I have never tried out. I think that sounds very good, and I think it makes a lot of sense and it will help a lot of projects. All right, thank you so much for taking the time and sharing best practices and product updates. So thanks you for being here and see you soon.
Thank you.
Bye. That's it for today's episode related to what is chaos engineering. We learned a couple of things, especially on the process of chaos engineering, listed a few tools, and we had the chance to interview one of the maintainers of the Litmus project. If you're interested in Litmus Chaos in details, stay tuned. There will be soon a dedicated episode on Litmus Chaos. If you enjoyed today's content, don't forget to like and subscribe to the channel. So stay tuned, more episodes will arrive. So thank you for watching and see you soon for another episode. Bye.